Light is a form of energy. Light is always travels in a straight line. This phenomena is called rectilinear propagation of light. Light is also travels in the form of waves. This is called dual nature of light. Dual nature of light means light travels in both in the form of corpuscles as well as in the form of waves. That is corpuscular theory as well as the wave theory of light. This we will discuss in future about the function of corpuscular theory and the dual nature of light, that is wave theory, in forthcoming classes. So the ray model of light has been very successful in explaining many aspects of behavior of light, such as refraction, formation of images by mirrors, lenses, etc., particularly in lenses. In physics, refraction is the change in direction of a wave passing from one medium to another medium, or from a gradual change in the medium. Refraction of light is the most commonly observed phenomenon, but other waves such as sound waves and water waves also experience a refraction. Refraction is responsible for several common optical illusions. When you look into a lake and see a fish, where is the fish located? That is the illusions. Special effects are the optical effects, the optical illusions. If you observe the fish in the water, this is the actual position, but thinking that this is the virtual image. So this is how the illusion or the optical effect is the important phenomena. This type of illusion of light is called refraction. Material and the index of refraction. Generally, the student should remember the important statistics available from science, that is vacuum, the light travels, and index refraction or refractive index is 1. Here is 1.00277 for optical measurements. The refractive index in vacuum as well as air remains the same, that is 1. Water is 1.3. Ice is 1.31. Water and ice is considered as 1.3 only. Glass about 1.5. Generally, glass, the refractive index of glass is 1.5. Diamond, it is 2.4. Diamond, which is the hardest material ever found in the world, is diamond. Let us discuss about the importance of diamond and its structure in the forthcoming classes, particularly allotropic forms of carbon. Let us remember all these refractive indices in our solving the problems in the question papers. Particularly, the student should remember the statistics of all the refractive indices. In optics, the refractive index or index of refraction of a material is a dimensionless number that describes how fast light travels through the material. It is defined as where c, that is the velocity of light, is speed of light in vacuum, and v is the phase velocity of light in medium. You see, refractive index, this is a measure how much light slows down when it goes into a new medium. The symbol is n, and n is the vacuum, that is equal to 1. N is equal to c by v, where n is called an index of refraction, and c is the velocity of light, and v is the velocity of light in the medium. C is the velocity of light in the vacuum. So n is equal to c by v. That is the relation which helps to solve the problems in the examination. Well, friends, this is incident ray. Falls on the refractive surface or a glass slab or a water or whatever may be the medium. Incident ray starts from the rarer medium to denser medium like water or glass or diamond or whatever it may be. It undergoes refraction. It changes in its path. The ray of light changes in its path. It deviates. It changes in its path. Hence, and gets emerged. The Snell's law tells about n1 sin 1 theta 1 is equal to n2 sin theta 2. That is all about the Snell's law. Vvsma Academy tells about the Snell's law, which the relation is n1 by n2 is equal to sin theta 2 by sin theta 1. The medium smaller index of refraction, slowdowns, and theta 1 and theta 2 are the angle of incident and the angle as refraction, and the n1 and n2 represents the rarer medium and the denser medium. These are the important equations relating to Snell's law, which helps in solving the problems. Well friends, this is particularly refraction is responsible for several common optical illusions. When the straw or a scale or any object dipped in water, if you observe that it changes in its direction, and hence it disturbs the illusion as if it is not in a straight line. That is a straw or a scale or a tube or whatever it may be. Here in the rectangular glass slab, you can find the ray of light enters from a rarer medium and it gets refracted and it emerges out. This is incident ray, this is a refracted ray, and this is the emergent ray. This is a rectangular glass slab. This phenomena tells about the refraction of light. When you watch a person standing in waist deep water, it appears that their legs are shorter. Explain this observation using a scientific annotated ray diagram which relates to the phenomena of refraction. This is for your home assignment. You please draw a diagram represents the refraction of light as we have discussed in the rectangular glass slab, incident ray, reflected ray, and the emergent ray. See, the incident ray gives theta 1 and the theta 2, the refracted ray. This is the air, that is a rarer medium, n1 is equal to 1.0, and this is a rectangular glass slab or any optical medium which is a denser medium. For example, glass n2, that is the refractive index is 1.5. That is the ray transmitted incident ray, and incident ray starts from the rarer medium and enters into the denser medium, refracted ray, and this is a transmitted ray, same direction of propagation as incident ray, but the transmitted ray